This tutorial is rated CF for computationally frustrating. Programmer discretion is advised. Welcome to How to Compile TensorFlow 1.12 for macOS. Let's start with a quick demo comparing the public TensorFlow build versus the custom compiled version we'll generate by the end of this tutorial. Since TensorFlow is basically a huge Python library, let's be polite Python citizens and run everything inside a virtual environment. Now let's jump inside our virtual environment and install public TensorFlow with IPython for some quick performance testing. Just to test the public TensorFlow release, let's copy a simple example from the TensorFlow Getting Started site. The first thing we do is switch this code example to dark code mode, because dark code is more trustworthy than light code. Now we copy the example code back into IPython and we hit enter a few times until IPython decides to let us run the code we pasted. Oh look! A big warning saying the TensorFlow package doesn't support all of our CPU hardware features. Well, that's what this tutorial is here to fix. So a little more waiting, and it looks like each of these steps is taking about 100 microseconds, so that's going to be our baseline performance for the public TensorFlow release here. And we're done. Those are the preliminary results from the public TensorFlow release. Now let's do the same with the custom compiled TensorFlow that we're going to generate by the end of this tutorial. Same as before, we jump inside a virtual environment, except in this one we have already installed our custom TensorFlow that we'll build at the end of this tutorial. We launch IPython, paste in the sample network from before, except this time we have a few more configuration parameters we're going to define so we get the most optimization out of the optimizations that we optimized into our optimizations. And now we see training is taking around 90 microseconds, and oh look at that, 84 microseconds per step, instead of the previous one, which was, what, a little over 100 each time? So that's a free speed up with no code changes anywhere. Now that both of those are complete, let's just compare them real quick. Up top, we have the original public TensorFlow version that does around 100 microseconds per step. Down below, we have our custom compiled version with all of the optimizations enabled for our hardware, 85 to 90 microseconds per step, which doesn't sound like much, but when you're running some of these models CPU only, because TensorFlow doesn't support GPU on Mac, that can be a noticeable speed up if you're running these on larger networks than just stanky old little MNIST. So how about let's try to compile TensorFlow and see how it goes. But since this video is about 3 hours long, you can probably guess it doesn't go very well. The goal of all of this compiling is to basically remove this one TensorFlow warning we get when running the public version that's shaming us into having more CPU features than the compiled version knows about. Let's get started by pulling up the official TensorFlow build instructions. Install Homebrew. Check. Yeah, we've already got Homebrew installed. It's 2019. We know how to install Homebrew. Thanks, Google. Install Python 2. WT fuck Google. It's 2019. Why would anybody want to use Python 2? No, we're going to use Python 3. And we've already manually pinned our Homebrew install to use Python 3.6 because Python 3.7 just has problems and Homebrew doesn't give us a way to distinguish between Python 3.6 and Python 3.7. So if you want to follow along at home, manually install Python 3.6 using an old Homebrew keg. Now let's clone the TensorFlow repository and wait for everything to get pulled from GitHub. Oh look, we're downloading at 20 megabytes a second. And download, resolve some deltas, and we're almost ready to go. So, freshly cloned. Let's check all the version tags and pick a good one to run. We can list the tags sorted by the tag created date. So if we look all the way there on the right, it looks like the latest one that isn't an RC is version 1.12. Next up is a pretty simple routine we've probably done 1,000 times before. So all together now.
With my finger on the trigger, I run /configure. Yo, this package is big, but my package is bigger.
Install Bazel? What's a Bazel? Well, if we look back at the original build instructions, it says we need to install Bazel before we do any of this, so our fault. Let's install Bazel. Let's see if Homebrew has Bazel. Okay, Homebrew has Bazel. It looks like we're ready to go. Basic options are already set. The configure script detected our virtual environment. Everything is set to the right paths, and we can go from here. And let's disable this Apache Ignite thing, because we all know Apache is the place where software goes to die. But next up is this XLA thing. What's this XLA thing? Well, let's look it up. Oh, XLA is some sort of machine learning JIT. That sounds nice. Let's turn on XLA. And all other options default to no, which is good enough since we're compiling for a single system macOS without GPU support. TensorFlow doesn't support GPUs under macOS, so that's another great thank you to Google. So configuration is done, let's start a build. But we're using this Bazel thing, so it's not going to be a simple build command. Let's jump back to the instructions and find this weird incantation Google wants us to run. Of course, instead of generating makefiles, this Bazel thing has us run bazel build --config equal opt // tensorflow /tools /pip _ package build _ pip _ package. Thanks again, Google. You're doing great work. So in addition to that, we also want to build this MKL thing. We're going to also add --config equal MKL in addition to --config equal opt, in addition to // tensorflow /tools /pip package build pip package. And it failed. Why did it fail? Well, there's no way to know looking at this, so off we go to use Google's browser to ask Google why Google's build system failed to build Google's machine learning library. Thanks, Google. The first result has our exact error message. Now let's see if it's useful. It looks like this person is trying to compile TensorFlow without a network connection. So TensorFlow can't download its gigabytes of dependencies. That's not quite our problem. Also, you notice the reply is sending users to Stack Overflow, because no modern software project is complete unless you have 8 different methods of obtaining community support. Result 2. Let's see, skim it over. Nothing interesting so far. Lots of complaining, lots of pasting. And looks like some Java problem at the end, so not very likely our problem. Result 3, skim it over. Someone suggests TensorFlow can't be built with the latest version of Bazel. So Homebrew gave us Bazel version 20, while this user says use Bazel version 19. As you may have noticed in the official TensorFlow guide, nothing tells you which version of Bazel to use. It just says install Bazel and it'll work. So we also see a user chastising Google for exporting their internal million machine build server cluster system out to the real world without maintaining it. So result 4, let's skim it over again, same as result 3, except this problem is from almost a year ago, saying Bazel versions can't build TensorFlow versions. So result 5, it's over on Stack Overflow, doesn't look very relevant. Let's do a sub-result. Result 5a on Stack Overflow. A user confirms TensorFlow can't be built by the latest version of Bazel, which is mentioned in precisely zilch, nada, null, 0 places in the official TensorFlow documentation. Even though we can see from search results, people have been running into this problem for over a year now. It looks like we have to install a previous version of Bazel. Now we get to jump into Homebrew again. And since Homebrew doesn't allow users to install previous versions of tools, we have to do some manual hacks inside of Homebrew. So we quickly search for the Homebrew Bazel formula itself, then use the git history to go back a version. Now, copy the hashified URL so we can paste it back into brew. Now with a new version of Bazel installed, let's start this all over again. Bazel 19 still doesn't like the MKL option. Something still isn't working, but we don't know what yet, so let's just keep going for now. Looks like progress? It's working more than it did last time. So let's watch this for a while and see where it ends up. And an error again. Oh, this one is simple though. We forgot to install the Python dependencies for TensorFlow. So let's pull up the dependency list and just pip install these real quick inside of our virtual environment. We'll type the first few and copy and paste the last two because they're longer and more complicated. And it worked! Now back to resuming the build. All the dependency downloads are continuing, but look how slow the downloads are. I'm sitting here on a 300 megabit connection, and these are downloading at what, 100K per second? Isn't Google basically the entire internet by now? Hey Google, why are your mirror downloads so slow? We can download from GitHub at 20 megabytes per second. Why are we downloading these dependencies at 100K per second? Fix your mirror, Google. And we're finally compiling. Not too bad. It only took, insert number of minutes here, minutes to start compiling, even though the official instructions have been wrong a couple times so far. This also ignores the multi-day debugging problems we're not showing here because this 3-hour-long video is already way too long. This is a speed run of compiling TensorFlow through all its problems, and for your convenience, we've removed the multiple days of dead ends where problem solving just goes nowhere and you end up running in circles, wasting hours and hours and days of productive time that could have been solved by simply writing the instructions properly in the first place. Thanks, Google. joy, a compile error. What the heck is wrong now? TensorFlow generated 2 compile errors here, so let's take the first error and give it an old googly searchly. And the first result looks promising, based on the title alone. If we click through to it, and scroll down a bit, it looks like they're not quite trying to do the same thing. They're trying to do something with power platforms, which don't make sense these days when we have perfectly capable x86 platforms and perfectly capable x64 platforms and perfectly capable AMD 64 platforms to run all of our code. So this is just wasting people's time with a nonsense question. The second result has the TensorFlow GitHub bot yelling about proforma issues with nothing resolved at the end. The third result thinks there's a C++ problem, maybe. See Basil use CPP only toolchain equal 1. But does that really apply to our case here? And you scroll down some more. People are taking the error message literally, thinking it's a protobuf thing when it could be something else entirely. And even though this was closed months ago, there's still somebody commenting recently saying the problem is unresolved. But TensorFlow bot just closed it because nobody cares when bots run the world, right? So yeah, this was opened months and months ago, no resolution, just closed. So that didn't look promising. Let's try to narrow the query down and see if we can get it more suited to our individual situation. We generated a new link here. Let's look at the first one. So we wait for GitHub to load, scroll down a bit. People saying download pre-generated releases instead of compiling it yourself and everything will work fine. But that defeats the point of trying to compile it yourself. So another non-answer answer on an internet support forum, as we would expect. Let's narrow down the search query again. And what else do we have here? Scrolling, scrolling, scrolling. Not much looks too interesting. We can try to narrow our query down some more, because the error was something about an Objective-C flag passed to the compiler. Scroll down some more, and still nothing looks useful. So let's try an entirely new search with the other error message. TensorFlow was generating a weird compile flag f Objective-C link runtime, which doesn't seem that useful. Here it says maybe CC is wrong. It says Basil tries to detect the toolchain based on the platform. So since we're running on Mac, maybe there's some confusion there. But we have GCC and Clang installed, so it should be able to do the right thing, you would think. So if we go back, check the other error message. This is for a different platform compiler, which still isn't useful for us. Go back and scroll, 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 nothing useful. Narrow down more. If we make the search more generic, did anything happen there? Scroll, scroll, scroll. Nothing useful. Let's try an entirely new search query. TensorFlow Mac unrecognized command. So here's an issue from 2 years ago, complaining about compiling TensorFlow on Mac and getting unrecognized command options. And support says, no, dump your GCC compile options. And oh, look at this. Somebody says, because you're using GCC instead of Clang on a Mac, things may not work right. It looks like Basil is assuming that GCC will be aliased to Clang on a Mac. And so Basil is passing Clang options to GCC on macOS. That could be a problem because we actually have GCC installed as well. So our GCC is an actual GCC and not the default alias to Clang. So let's just try that. Switch it out, cc equal Clang. And it looks like things are continuing. TensorFlow spits out tons of warnings, because apparently they're using self-referential deprecated features inside of their own distribution, which you would think they wouldn't do, but hey, it's Google engineering, what do you expect? So that simple trade of cc equals Clang seems to have fixed something. The compile is proceeding more if we assume it's actually going in order and not just launching a dozen parallel compiles out of order and we're getting non-repeatable, non-deterministic compile output here. Oh look, another compile error. Can't find Aries.h? What's Aries doing here? Aries, whatever that is, wasn't listed as a dependency anywhere, and TensorFlow seems to have pre-downloaded all of its dependencies elsewhere. So what's this? Let's see if it's something we can install ourselves and just move on from. Okay, so there's a homebrew package called c-aries. Let's just homebrew install c-aries. And let's restart the compile from here. The compile seems to be running again, which looks okay, I guess? Hopefully. But TensorFlow or Bazel seems to be compiling everything in a completely non-deterministic order, so who knows if we actually ran through the error or fixed it or did anything that changed at all. Oh, there's the Aries error again. So apparently the dependency we installed didn't actually get picked up by TensorFlow. That's always encouraging. Well, let's see if we can find this Aries.h and make TensorFlow use it. Maybe something in TensorFlow or Bazel's just pointed at the wrong place? So 2 minutes after we restarted the build, it's crashed again in the same spot that we thought we fixed before. Thanks, Google. Back to the internet. Back to using Google's browser to ask Google why Google's build system can't build Google's machine learning library. The first result doesn't look entirely useful. There's something about a Bazel's CI problem which doesn't tell us anything about our problem. It just says somebody ran into the problem at some point and they fixed it, and nobody says what the fix was or what the actual problem was, so this is a pointless issue. Just says, you're missing a dependency, install the dependency. But we already did that and nothing worked, so let's move on to something else. The next one, another file not found error. And again, no real resolution. People just say, well, get it to work somehow. And the rest of the results here aren't really related to what we searched for. They're just backfilled results Google populated because Google didn't want to only show us 2 results. So that search was a dead end. Let's try a new search. If we make it a little more generic and take off the exact match parameters, we have a few more results to pick from here. This one is still a few months old. And it's just more Bazel problems, more people joining into the conversation saying they have the exact same issue and they can't solve it. And all of these problems have just gone ignored by everybody, the Bazel team, the TensorFlow team, all the contributors to the issues. People are either solving the problem and not contributing answers back, or the problem has just gone unsolved and nobody can figure out how to build TensorFlow unless you work at Google, perhaps? And some of these answers are trying to get you to modify the TensorFlow Bazel config internally, which seems like something we should not have to do from a release branch that has been known to work somehow. Like somehow Google generated the release pip package of TensorFlow for us, and we just need to figure out how to do it ourselves. Here's somebody offering a suggestion, which is something we tried before, but maybe we did it wrong. Here they're saying TensorFlow compiles under Bazel 18, and we started with Bazel 20, then we backed up to Bazel 19, so maybe we need 18 instead? So apparently we need a 3-version-old copy of Google's build system to build Google's machine learning library, even though none of this is mentioned anywhere. Let's just jump back over to the homebrew repository in the Bazel history, grab the Bazel formula for 18, copy the URL for the persistent Bazel 18 version, then jump back into our terminal, uninstall the current Bazel 19, while we watch Homebrew complain that Bazel 20 is available, so why aren't we using Bazel 20? Well, apparently Bazel is so feature unstable across these point releases that we need to go back 3 versions in order to compile modern software. Thanks, Google. Download, download, download. We watch the download, download. We play the download, download, download game. And the download is almost complete. So with Bazel 18 installed, we want to completely erase our build tree because the build system is entirely different now. So we Bazel clean -- expunge. What is Bazel cleaning? What is Bazel expunging? We don't really know. Bazel still detects our Python virtual environment, so we use those. We disable some Apache garbage, we enable XLA, and then we hit default to everything else. And this time we're going to try to run with the -- config equal MKL option again, because for some reason Bazel 20 and Bazel 19 rejected that option. But if this is the one true Bazel version, maybe it will work. And we can see TensorFlow is immediately downloading the MKL dependency for us. And it seems to have skipped all of the other dependencies it was downloading before. So I guess Bazel clean -- expunge doesn't clean previously downloaded dependencies. So here we go. We're running 8 concurrent compiles at the same time, and we just have to let this sit here for a while and see how far it goes before crashing again. What? Another error dare present itself to our sacred terminal? Time to ask Google once again why Google's build system can't build Google's machine learning library. The first result seems to have an answer for us, actually, and it references an older issue from over 5 months ago, which still hasn't been fixed in any official releases. Look down here. People are still asking about the problem because, well, it's a catastrophic, unrecoverable build error, and it can't be fixed without seemingly manually editing build files in the repository. Let's do this manual edit of this file in the build system. Let's search for exported _ symbols real quick. Oh, we can fix this pretty easy. Just do a line join and a quick quote-ectomy. Do a right quit and see if the build will continue. So does the build continue? Let's give it a try. Is it done? Did we actually compile TensorFlow this time after 3 hours? And now we have to figure out how to turn this compiled TensorFlow monstrosity into an actual pip package we can install into our Python virtual environment. So according to the official instructions, it looks like the way we build a pip package from this TensorFlow compile is this very intuitive command.
/bazel-bin/tensorflow/tool/pip_package/build_pip_package.
And then the directory where you want your package to be generated. So let's run this and see what happens. And the final file was processed and generated. So all we have to do is point a pip install to that direct file path, and it should install in our virtual environment. It looks like it installed. It grabbed all the dependencies it thinks it wants, and we should be able to just import TensorFlow and go from there. Oh, except we can't do that because we're in the TensorFlow repository directory, and apparently TensorFlow has some Python magic saying you can't do that. So let's jump up to the parent directory and try to import TensorFlow again. TensorFlow actually imported. It worked. After 3 hours, let's just try to read some static properties from inside TensorFlow to see if it's using the right thing. And it worked. It did work. There we go. For a quick example of using the custom compiled TensorFlow package in action, jump back to the beginning of the video where we ran a performance test against the public TensorFlow package versus this compiled package we just generated. Basically, with this compiled package, since it's using MKL, you want to set some performance optimization parameters. And as a quick note, this version of TensorFlow also has a mild locking bug with MKL. So if you notice a slowdown versus the original public version that isn't custom compiled for your CPU, just go back and disable that --config equal MKL option and recompile everything without MKL getting in the way. Then in a few more Tensor versions, hopefully when Google and Intel get their act together, you can go back and re-enable MKL for the most performance possible. Thank you for attending the inaugural episode of Your Code is Bad and You Should Feel Bad, TensorFlow Compiling Edition. We have 45 more ideas for episodes lined up across different software projects, but seeing as it took us about 5 weeks to make this one episode, the next one might be a while. Thanks for watching. We'll see you again soon.